Hi, my name is Dr. Sachin and I'm an application specialist in static control, and I use ionization as a technology to remove static charges from various surfaces and eliminating ESD and ESA in different applications. Nozzle edge, I'm going to demonstrate the feature called as ESA, electrostatic attraction. Static also is responsible for contamination. We call it in the name of ESA, electrostatic attraction. Electrostatic attraction or microcontamination is a resultant where the dust particles, basically the smaller charge particle, attracts to a surface which has got a higher charge. So I'll be using the same nozzle edge here to basically remove the static charge from a surface. My colleague here will be helping me with styrofoam beads. Here we have used the styrofoam here for basically showing the attraction. So right now I'm powering up the nozzle, okay, and we'll be giving a bit of air also, but presently we will just charge this particular sheet. Yeah. So by rubbing this particular plastic sheet over an insulative surface, we are hoping to generate quite a bit of charge. And there you can see there's a lot of attraction which happens to this particular sheet. Now this is what is primarily called as ESA, and this is what is the reason why dust gets attracted to surfaces or something like that. Now what I'll do is ionize this particular sheet, and to show you where exactly the attraction is missing. Yeah. So what I'm going to do is let me get it a little away because yeah. I've ionized this sheet, and now you can see the attraction would have completely disappeared. So this is what exactly is trying to remove the ESA or something like that. We will do this once again, probably not before the styrofoam, but this thing. So right now it has a lot of static. So what I'm doing is I will be using, yeah, and let us try for the attraction. You can see that the attraction, there's nil amount of attraction or something like that. Yeah. In my last trial, I would like to do this again. We're charging the sheet up by rubbing friction. So you can see the particles attracted to it. So we'll just manually try to remove the particles, and so I've ionized the sheet, remove the static, and so basically static is nozzle edge, end nozzle I've used to remove static and eliminate ESA. Nozzle edge, this is the end nozzle from Simco Ion USA factory. The power supply is D257Q. Yeah. Thank you for watching our video. Please come back for more and more videos. End nozzle. This is the Simco Ion US make, and this is typically an end nozzle. The end nozzle is one which basically is put at the last. For example, if you have a daisy chain, you will have multiple numbers of through nozzles, and at the last you will have this end nozzle. Typically you can also see you will have this flare nuts, so they will have certain kind of openings for the emitter pin to be available for cleaning purposes and stuff like that. Yeah. The power supply which we are using which can take additional load. The power supply is D257Q power supply. So this can take higher loads, and you can put multiple number of nozzles. It's a very simple nozzle, just plug and play, nothing very difficult about it. Earthing is very necessary. So if you can see that I have now made temporary arrangements of grounding the power supply and grounding the nozzle separately. So these two are very necessary. If you do not give any grounding or earthing, a risk of shock is there, which is obviously very mild, but the main thing is the ionization doesn't take place unless you do the proper earthing. So we have a bus bar here where we should be connecting it for earthing. This is just a common bus bar which is going to earth pit outside. So this way both the nozzle as well as the power supply is connected to the earth. The air is already plugged in. I am giving typically right now about 2 or 3 bar air pressure, which I will be using to basically do a small testing. The power supply we'll be giving it to 230 volt AC. I'm using this connector because this is the standard pin which it comes with, and this is what will make it run. I'll be using electrostatic field meter. The latest one from Simco is FMX004. it has a very high range. It can measure up to 30 kV, plus or minus 30 kV of range, and low of 3 kV, and iron balance up to plus or minus 300 volts. A simple device which you just press it, and wherever these two lights meet, you should be able to take a reading. You should not be too far, you should not be too close. Ideally, I would like to show you how it works. Is like, let us say you want to check static on this document. You should point it at this particular distance. So this is the instrument which we are going to see before and after. A simple test for this ionizing nozzle is what we are going to conduct. Okay, so we get into testing. There are a couple of fixtures also I would like to explain to you. These are the standard clamps which will come. It's a very simple thing. It provides you two options. You can actually screw this up here. These are mounting provisions. You can have your own mounting provision depending upon how it is. So this gives you a lot of flexibility. You can mount it. You change the distance how much you want. There are certain people who even cut the length of this depending upon how their machine fixture is. So this makes it very easy fixture to mount at different angles, however you mount. And always I recommend you should use both the points so that the nozzle is fixed strongly. And this is the cable. This screw actually enables you to put an HV cable. You can have an additional length of the HV cable. This is standard, I think. So I'm having about 3 meters length of cable. So coming to the connection part, okay, just let me get off these. I don't need them now for the trial. Yeah. So it's a very simple connection. The power supply has two output ports, output 1 and output 2. I can connect this to output 1. It's a very simple thing. It comes with a spring loaded connection. The spring loaded connection ensures that it is tightly connected all the time. So you will find a little bit of pressure when you're tightening the screw inside. So you just put this and you have to apply a little bit of pressure so that this locks in. If you normally just try to screw in, you will be seeing that it moves very freely, but whereas doesn't lock in. So after this you'll be able to see where it locks in. Do not try to lock in too hard because these are like plastic connectors. They would like just give up after some time, just firmly locked or something like that. So this is how it is. Ensure it is firmly locked, not too tight, not too loose also. So the electrical connections are ready. Once again, check the earthing is proper, because earthing is the one which is necessary for proper functioning or something like that. I'll just loosen up the cable a little bit so it gives me a flexibility to show you the testing. So now we are ready to this thing. So powering up the power supply, so I have completed all the electrical connections, connected the thing to HV. So basically the one way to test is like I just switched on and just check the HV. This is a HV pen, and you can see that whenever there is a HV field around it, it will just tend to glow up. So that is one way to just figure out whether this is working or not. So trying to see whether this thing. So currently the HV is available at this particular nozzle at the emitter pin, and this is the HV cable. The entire HV cable lights up. So now we will be giving the air supply. I'm going ahead with a slightly moderate air supply. Okay, and now it is ready for ionization. Probably just for the test part, I am using about, this should be about 1 bar, half a bar of pressure to just test to show you exactly how this is. My colleague here will, just use a tape. Yeah. So we are using basically a packing tape, which is essentially what he is doing is he is doing separation and is showing the static measurement on it. Okay. Now we'll use a nozzle to remove the static charges. Okay, and there you go. The readings have almost neutralized with hardly about less than about 100 volts of charge on it. So this is what it is, and probably we'll do another trial. So my colleague will again do this. Yeah. So this is now right now reading about 10 kV or something like that. That is what we can reach. Just the kind of reading we are getting. So we'll use the nozzle to ionize this thing. Yeah. So ideally you can see the reading, so showing that the tape is completely neutralized. So this is how effective the HS nozzle is. That concludes our video. Thank you. The standard HS nozzle comes with this flare. You will be able to see this kind of holes. This is the standard nut which you get the nozzle opening nut. It will be having the flares or something like that. But you can also order the special kind of thing. Let us say if you are working in an area which has got a lot of powdering material or something like that, and your emitter pin tends to attract that particular powder, so you can use this particular nut. You have to order this. It's an optional, but you can order this. This doesn't have any nut, and it can be changed. It's a very simple device, simple method to change it or something like that. So let's just power it up and just see. So turning off this thing, power, and again doing our test with a volt stick just to check. So you can see there is HV high voltage is available. The volt stick, the 10 sign pen will indicate that there is HV power available to this particular device. So now we will do the static testing using this particular thing. The nut is called as without flare openings or something like that. Yeah. So we just switch on the bar. I am essentially, I think it's about half a bar of air or something like that. So we'll be doing a kind of this thing. My colleague Kishore will be helping me out. Kishore, could you just remove the tape? Just open the tape. Yeah, and just can you see the static? So the reading is about 4.5, 4 kV or something like that. Let us do the ionization. Let us try to remove the static charge. So we have just removed the static charge. And yes, there is neutralized it. So we'll do another trial. Yeah. So trial number 2, you are able to see about maximum of 9 kV, and we'll try to neutralize this. Yeah. So it's completely neutralized with maximum of 10 volts or something like that. Yeah. This concludes the testing of HS nozzle without flare nut holes. Yeah.